An AI oracle, a machine that you can just feed with information and your goal, and it will give you the most optimal thing to do to achieve this goal. On this podcast, I have two goals. The first goal is to try to find the most optimal goals. So this is more philosophical. But the second goal, this is what it is about today, is to try to find the most optimal ways to achieve those goals. And for now, I'm trying to do this by hand. So I'm really trying to find all the information, read all the studies, and then try to, from that, find the right ways to achieve my goals. But this is so incredibly hard, and the world is so incredibly complicated. So I was thinking if it might be possible to build an AI that could take this burden from us, that an AI that could do the reasoning for us, build a general reasoning machine that you can feed with information and your goals, and it will just output you the best thing you can do because it's able to reason. So I was asking a friend of mine. His name is Andrei Lixandru, and he's a master's student of cognitive computing and artificial intelligence. So he really knows his shit. And yeah, I was asking him about this, and he walked me through this idea of building an AI oracle. He explained the different ways this might be achieved, the different types of AIs that are used nowadays, and he explained what opportunities and drawbacks each of the ideas have, and yeah, how we might go about doing that. So the main premise for this podcast is that the world is incredibly complicated. Even like the most simple thing I can think of, like how much creatine should I take, or like should I take creatine? Like there are so many studies that explain why creatine is good, for what creatine is good, but even this, it's like, okay, but how much exactly? At what time? How often? Should I load, not load? Should I does and that's not only it, like that's not only it, because we can't find like one general thing, because it's all also dependent on like your body type, maybe your gender, maybe your weight, maybe there are so many variables. And you might say, oh, this is all too complicated for me, I just take like this amount of creatine and it's going to be fine. And yeah, this is the way I live my life as well at the moment, because as humans we can't do that. Like we can't deal with all this complexity, or we could, but it would take us like years and years and years for just such a simple decision of how much creatine or at what time to take the creatine. And like this was like one of the most simple example. Like I have so many more complicated examples where if you try, for example, if you want to increase your happiness, like there are so incredibly many variables that play in there. Like even what is happiness, everything, but also like economics. And a really good example is like sports. Like everybody knows that sports is good for you. So if you want to be healthy, do sports. But what type of sport? Like the problem is there are not only 3 types of sport that you could like compare to each other and then decide like, okay, I either do jogging, weightlifting, or swimming, and then you compare. But there is no one jogging, there's no one weightlifting, there's no one swimming. Like how far are you gonna jog? How often are you gonna jog? How fast are you gonna jog? What types of shoes are you gonna wear? What is like, what type of walking are you gonna do? Do you do stretching before? Like the same with weightlifting. What exercise do you do? It's like there are so infinitely many opportunities, and like this is kind of amazing. Like there are so many opportunities that we could try to find the best, but as humans it's just not possible. Like you just have to choose something. But it would be so amazing to build something that could tell you, a machine that could go through all the studies and all the information that we humans have collected, and then it could just tell us in like with also taking account our goals and our personal, like I mainly gave health examples, but not only for health, but it takes our personal situation into account with all this information and with our personal goals, and then it just tells us what's the right thing. I really want to have something like this, and I am absolutely ready to put a lot of effort into building something like this. So maybe if you also get inspired by this podcast or you know something about it, contact me like on Instagram or something. It would be amazing. And yeah, as I said, I'm so ready to work for it. But the main thing that I was trying to say in this introduction is that the world is incredibly complicated. And now, Andrei Lixandru. I forgot to mention, for this podcast, I don't have the video, sadly, but I just clipped those little microphones onto me and Andrei while we were cooking our dinner and eating dinner, and while he was explaining this to me. So, no video today, but still an incredibly valuable conversation.
Okay, and now I try to have the best possible goals and the best possible way to follow them. And even if you don't try to have the best possible goals, but even if you just have a goal. Let's say life is simple. You just have a goal.
Get a Porsche.
Yeah. How? If you want to find the best way to
How do you go from no Porsche to Porsche?
No, or just if you want to understand more. If you want to understand more, then at some point, like my goal is somehow to understand the world. You know, it's like I want to understand everything. Like and the world is so complex that as a human, I will never be able to understand everything. Like. The world is like...
As a human.
Yeah, exactly. That's the key. And
that's the keyword here.
The thing why I'm talking to you about this is because I was thinking about, is it possible to build some AI, whatever, that you can feed all information? Like, for example, I feed it all the information we have about creatine, as an example. And then I feed it all the information I have about me, and... then it calculates, it says to me exactly if I should take creatine, how much I should take, when I should, like, this is just like creatine is just like a random example. You could like...
Should Elias take creatine?
Yeah.
How? What should Elias do with creatine? That's the question.
And they're like, it takes into account every variable. So also like, it takes also the risk, also like, because like it's fine, like if there's a little bit of risk, it's still fine to take it. But if it's too much risk, it's not, or maybe you should take less because of risk, or like it also takes into account the risk. It also takes into account my risk tolerance, and it also takes into account the cost. You know, like because it also costs a little bit of money, it costs a little bit of time, it costs a little bit of effort, and like some things are just not worth it for the cost because like the possible or the benefit to risk ratio, like the cost benefit ratio is not worth it, and maybe for creatine it would be not
like you getting a cryogenic chamber would be ridiculous because you have to spend all your money for the next 3 years
exactly
on a cryogenic chamber.
Exactly, and it also calculates how much worth money is for me. You know, like because for a millionaire it will be a different thing, because for a millionaire maybe I would tell him, bro, just buy your own cryogenic chamber so you can go there in the afternoon every day. But for me, it's a different story because I am not a billionaire, you know, or millionaire.
Yeah.
Okay, so it also calculates how much money is worth for me, and like it can take like you give it all the variables and it helps you spit you out an answer. But it's like not like random, but it like a reasoning machine, a machine that can help you with reasoning, and it can also I don't know if it like the best thing would be also if it could give you like the exact reasons for what it does. And build like real arguments, but the outcome, the valid outcome would be the most important thing. Do you think this would be possible to build?
The outcome would be the most important thing.
Yeah, like the number should be right, or should be like the grams the grams of creatine gives me like says me to take in the end. This should
at what time?
Yeah, and
under which circumstances?
And under which circumstances exactly. This like I feed it everything. I also feed it like the data from my Apple Watch, like my resting heart rate and my when I work out and stuff. Like as much as like give it as much data as possible, and so it can give you like the best the best possible outcome. And exactly, yeah, okay. Could you build something that is better than like humans working on? Like imagine I have like 10 humans sitting in a room that calculate all my. Can I build something that works better than this, or works as good as this?
Okay. So I have several thoughts. So do you want to know everything, or do you want to know more than a team of 10 experts?
Like if we're at the point of 10 experts, I think we're already on a pretty good way towards everything. Like, I want it to give me the best possible solution for the information it has. So I'm not expecting it to know things.
The best possible solution for the
information I give it. Like, I feed it information, and it should give me, like, it should reason its way to the best possible action from this information. So if my information is, this is my goal, those are this is the data I have. Now tell me what to do. Tell me what to do. Exactly.
In principle, given what we know in theory, in proven theories, not only hypotheses, about how our cutting-edge AI systems function.
Like LLMs,
in principle,
or large language models, or
no,
sorry,
neural networks.
Okay. Yeah.
So, given what we know about neural networks, in principle, the answer is yes.
Wait.
Is yes to the question of better than 10 experts. Of ultimately, the best possible thing given the information possible, the information available, you have to be way more specific. So, for what time scale are we talking about here? For the whole universe? For the next 10 minutes? Only for you or for other people?
No. Just, I give it goals, and I give it, I just give it goals, and I give it data. And it gives me the best possible action to get closer to these goals. So, and the best thing would be also reasoning for why. This would be amazing, because so I know, like, when it gives me, like, oh, the best thing you could do is to kill yourself, and I'm like,
but why? Wait, but why?
Why exactly? How did you come up with this answer? Or like if the answer would be like 39 or whatever, or what was it? In
42.
Like 42. Then I would be like, please tell me why. Explain. So I would also like. Yeah, given all the information I have about, like, all the information I give it and the goal I give it, it should give me the best action to do.
Plus a reason.
Optimally, yes. But it's more important that the action is right than that it gives me reasons. If I can somehow trust the action, if I trust that the action is the best thing, like, maybe it would be fine if you test it and like many times you test it and you reason, like, you have your team of 10 experts and then you compare, like, okay, yeah, the AI is, because I think if you have enough if you have information, like a goal information, you can come up with the best possible, you can't come up with the best possible way in the universe, but you can come up with the best possible action given your information, you know?
Yeah.
So there are for sure better and worse actions, and like if you include like risk tolerance and stuff, and yeah, tell me.
You told me your ramblings. I will also tell my ramblings about your ramblings. So in principle, the answer is yes. Given what has been proven about neural networks, you only need a 3-layered feed forward. So the most basic neural network there is. No recurrence, no convolution, just a basic bridge neural network. Information just passes through it, from bottom to the top. You only need 3-layer neural network in the limit to approximate any function, any possible function. Now, why is this useful? Well, because if you believe in determinism, then the universe is a function. There are phenomena that interact with each other. There are phenomena that interact based on rules, that function based on rules. And those rules can all be summed up in a function. So if you believe there is nothing else to the universe than physical laws, and that if you know every position of every atom in the universe and beyond, every quantum foam, if you know the state of the universe right now to infinite precision, then if you believe in determinism and you also know all the rules of the universe, you can predict anything that was and anything that will ever be.
Will ever be, yes.
And that would mean also knowing what's the optimal thing to do, I suppose.
You think so? Is it the same?
Okay.
Is it? Bro, I don't...
It's related.
No, it is. Or, nah, if you build such a... Bro, if you build such a function...
You're fucked.
It can't work, it can work. Can it work? Because if the function tells you something and based on what it tells you about the future, you change your action, if you change your action based on what it tells you about the future.
Okay, we have to make some assumptions here.
Yeah.
So, for the purposes of the question,
Yeah.
if there is only one possible configuration of the universe and we are all predetermined and condemned to take every shitty and genius decision through our lives, and there's only one option that we're all gonna follow, and there's no real choice in it, then wondering about what's the optimal thing to do next is meaningless.
Yeah.
But we act like we have a choice, and we are not condemned to live our lives based on what's outside our control. We make plans, we learn, we improvise, we have obsidian. We see possible configurations of the universe, we see possible paths to take in life. You jumping off the balcony, or you cutting that sweet pomelo. And it feels like you have control over that, which path you take. So, okay, given this framework, let's suppose there are multiple paths in the universe, and the AI can tell you, the neural network with 3 layers can tell you, all right, I know everything there is to know. I can compute anything that can be computed. I can process any information in the most optimal way.
No, I don't want...
I can tell you all the possible ways in the universe. Okay, you want this way, you want this path to follow. I will tell you exactly what to do to follow this path.
you want this outcome, I tell you exactly what to do to get this outcome.
Yeah, exactly.
Yeah, exactly.
Okay.
Yeah.
So that in principle is possible,
Okay.
but in the limit. Let me tell you more about the limit situation. So the limit meaning an infinite amount of neurons in each layer. So you have 3 layers, but you have infinite neurons in those layers. And given enough information, given enough data. So you not only need a system with infinite neurons that can multiply its neurons to infinity, but you also need it to go around the world and get to know everything. So for practical purposes, it's pretty impossible. Okay, now let me so this is the top-down view. Given what's in principle possible, yes, the answer is yes. Now, the bottom-up view, given what we know so far about AI and what AI did so far and what AI proved it can do, like stuff we already are doing, not only theory of what AI can do, but stuff AI already did. I would say also the answer is yes, functionally speaking. Now, this we also have, but for this, it's not in the limit, but we have to push the limits. Because if this would have been possible, someone else would have done it already, and we would have had a proper oracle, not just ChatGPT.
Wait, the thing is, Andrei, I don't want of course, I would love an oracle, but oracle means that you give it all the possible information. And I just want a system that, let's say,
can do optimal decisions under limited information.
Exactly, under limited information.
Yeah,
exactly.
yeah.
Exactly. This is the definition of what I want. A system that can do optimal decisions under limited information with exactly.
Okay. Now,
in a complex system.
The problem in a complex system.
In a complex system, because the world is a complex system.
Yeah. Like if the world was a bloody. If the world was a Euclidean plane.
Yeah.
With no imperfections.
Exactly.
It would all be way easier.
I'm not talking about, but optimal information under it doesn't have to be the perfect decision in the complex system. It just needs to be the perfect decision given the incomplete information you have.
Okay.
So we don't need the perfect decision. We need just the best decision you can make with the information you have.
All right. So now from the bottom-up view of doing stuff, solving this problem with what we already have, there are possible ways of going at it. But we would have to push the limits of what's out there. We would have to do new things. I cannot code you one line right now, or search something on Google and find, or ask ChatGPT for, just give it a prompt right now and give you the answer. We would have to improve AI to achieve this. Okay, so this is a huge problem, which also concerns me. Like, this is what I want to see AI doing. This is what I'm most interested in right now. My highest priority in AI is a system that does optimal
decision under limited. Yeah.
Not only that, but a system that achieves superhuman performance on a given task by learning from experience, from its interactions with the world.
Just say a system that makes optimal decisions under limited information.
But we'll never know what an optimal decision is, bro. We only know what humans do.
No, stop. You can okay, wait. If you have limited information, of course you can know what the optimal decision.
Depends on the problem. In a complex system, and the system you're referring to, which don't have the words right now to articulate, but
Like the world.
in the
yeah.
sense you're referring to complex systems, you will never know what's the optimal thing that could have been done, because you will never be able to simulate the system.
Okay.
So, okay, you'll take a decision, okay? I'm taking creatine. Do I take creatine right now at 9 a.m. or at 9 p.m. before I go to bed?
But
You do this,
You can also
you
give
see what
feedback.
happens.
Yeah, exactly. Feedback, learn from.
Yeah, yeah.
I just gave Andrei a pomelo.
Fill it up, man, fill it up. Okay, now, dude, let me tell you the efforts in AI that are related to this.
Yeah.
So, the most promising directions I see so far in this program are first, reinforcement learning. Now, this is a learning framework in AI in which a system learns from experience rather than from example. In supervised learning, in how you train a system, how you traditionally train a neural network to classify pictures of cats or pictures of dogs, is by feeding it the picture, letting it do a prediction, then telling it if the prediction is right or wrong, if it's a cat or if it's a dog, and then it getting an error signal, the difference between its prediction and the true label that you give it, the example. Example is, you give it the picture, your network passes it through, outputs cat or dog, and the probabilities. 70% dog, 30% cat. Now you give it the example, the label. You say, no, it is 100% dog and 0% cat.
Yeah.
And then the neural network computes the difference between 70% and 100 and 30 and 0. And based on that difference, adapts its parameters, changes its brain, basically.
Yeah.
Adapts to the environment. But you need the example.
Exactly, and this is not. You can't give it like, okay, read
And
those five studies and
if you didn't do something new,
yeah.
what example can you give it? Like, okay, I've never seen aliens before. Let's peel these bad boys.
You have to peel them.
Yeah, man, that's
Yeah, I did. I gave you the thing with the peel. I'm sorry.
it's okay, man.
I think
So-
this is done.
If you're in the context of a real world interaction of
So the thing.
like if you have a robot
Yeah.
and you want this robot to peel this pomelo,
Yeah.
you give the camera and you give it two robotic arms. Now, how on God's green earth are you gonna train this thing by example? Because for every frame it sees, you'd have to label it within the label, bad or good. Good, keep on going with the peeling. Oh, you drop the pomelo, bad.
Yeah.
Okay, pick it up. How do we pick it up? Well, good, bad, good, bad, good, bad. Now, imagine how many human examples, just human going through millions and billions of
Saying
frames.
Good, bad, good. Yeah.
Of frames, not only frames, but also
Different parts of frames. Like in this frame,
Exactly.
you move, like in this,
Like,
and in this, and in this.
everything. I do this, and it's a whole nother thing.
Yeah.
It's a different fucking thing if I move the box 1 millimeter to the left. The shades change, the light changes, the angle changes. Everything changes in terms of pixel values. Not only that, but the joint positions and configurations, the joint angles, the position of the arm, just the combinatorial explosion. You have so many
Exactly.
possibilities
Yeah. Exactly.
that you cannot have a human going through all of them and saying good, bad, good. How do we address this problem? So learning from example works in certain circumstances, but if you want the thing to go in the world and learn from itself for itself, it's impossible. It just explodes.
No, wait. It's impossible to train in this way. But is
Yeah.
there another way?
Well, that way is called reinforcement learning, in which rather than learning from example, you learn from experience. What does it mean?
Just so we don't forget it. Do we? I would like a system that, like, something that we can build in not too far of a future, and something that that can work with real life. Like, you give it like, okay, we have this study. This is my experience in this situation. This happened. Like a mixture of different inputs. Like you don't only give it like, oh, cat dog input, but you give it like, okay, this is the information I have. Like, I have here my HRV data. I have my risk tolerance. Like this is how I think about risks. This is how valuable money is for me.
So, let's say,
Yeah.
okay, it has general intelligence, not only visual intelligence, figuring out objects are in the world.
Yeah.
Not only physical intelligence of interacting with the world through its body, but also inference intelligence, extrapolation, induction, deduction.
Exactly. Exactly.
Okay, so this is what we refer to as AGI, the holy grail. The holy grail of AI.
So,
A system that is so adaptive, an artificial system that is so adaptive, that cannot outperform, okay, this is artificial super intelligence.
yeah.
AGI can also include human level intelligence, just making an artificial human. But what I'm interested in is to have a system so adaptive that it can outperform humans in any possible task that humans can do right now.
And this would be also
And
reasoning.
this also includes reasoning
Yeah.
and giving arguments and explanations for why you did what you did.
So you want to build AGI?
But I don't care about its feelings necessarily. Like, I don't want to build,
No,
I care about its function.
exactly. It doesn't have to have feelings. Okay. It just has to give you the right output. If you give it a task, it should do it better than a human.
Yeah.
Okay. It doesn't have to feel good about it or bad or anything.
No, I'm not, okay, now this is a further goal of understanding. This is an extra goal, like something you get for free if you do this. And the project of understanding how humans work and mind and consciousness and all the human magic fuckery that let us rule the world. That brought us from naked, scared, shitless apes starving in a cave to just globalized civilizations
Dressed scared to do that.
and basically cyborgs. We have bloody obsidians to just turning our environment into our brains with stuff like obsidian or the internet or Google.
yeah.
Yeah, okay. So AGI. Now this is fucking huge. And people in the 1950s thought they're gonna solve it in 10 years.
Yeah.
Like at Plymouth, I think, when everything with the AGI got formalized in the US, they were like, okay, we're gonna get all these people all together working in AI related stuff, and we're gonna make a plan, and we're gonna tell society in how long it's gonna take us until we solve intelligence, until we make an artificial system that can do everything humans do and better. Humans do and better. Now, this was in the 1950 something. We're still pretty far from that.
Okay. I don't.
So it's a huge project.
I don't need a system.
Now, I'm gonna tell you what interested me most in this project and what are the most urgent directions I want to go in.
Wait. Can we before? For my question, I don't need a system that can do everything better than humans. I just need this specific task. I want to give it information and goals, and it should give me the best. Like this is the specific task I wanted to have to be better than humans, or I wanted to be better than humans in this. I wanted to be better in humans to make given it information and given the information, limited information, make the best possible decision. This is what I wanted to do. I just need the functionality that I give input, like I give information, and this machine gives me the optimal action based on this information I give it. Just this.
So my best guess is, now if you want to tell you what you should do, you can use ChatGPT.
But
Now, ChatGPT
I
will
want-
never give you a valid answer for something that is niche enough.
yeah, I don't want
It's
just
pretty flaky.
just like the average answer of all the internet to like this question. The most I want the best answer based on the information I give.
You could train your own language model. Or you can fine-tune the GPT. They did that for clinical text. They trained the large language model from scratch. Okay, 1/10, just 10 times smaller than ChatGPT. They trained it from scratch only on medical text. Make some medical expert system.
But will this give me? Because I think large language models, they just give you like some answer that is like kind of approximated, but it doesn't understand. Like,
So the problem is, once you ask it,
will it really understand? Okay, this is the information we have on creatine, and this is like connected to your body type. This is what you should do.
Yeah. So there are two types of large language model. There are two stages. First, foundation, building the foundation model. Second, tuning the foundation model for a certain functionality. Foundation model, you feed all of the internet to a huge network of 100 billion parameters. That all it learns is based on a context. What is the word in this place? So you give it a document, choose a word, cover the word, based on the context, predict the word. And it does this for a huge chunk of the internet.
And it's really good. Yeah.
And now, this is pretty useless at this stage of foundation.
This is how
Because
okay.
all you can give it are prompts. Why do we need a prompt? Because the thing can only put a word somewhere that seems to be most probable. And this also includes end, like the symbol that this document should end here, or a comma, or everything in language. So you give it a prompt, alias is, and then completes the sentence. And it completes it until the most probable thing it believes is the end. Now, it does this very good for a lot of tasks. So if you give it translation tasks, in which you give it a few examples of something in English, arrow, something in German, something in English, arrow, something in German, then on the fifth try, you can give it something from scratch, something in English with an arrow, and it will complete something in German, which is correct as a translation. But you cannot ask it to do something and it doing what you should. You cannot be, what does
this mean in English?
Yeah. Because it wasn't trained on doing that. It was trained on predicting the next thing and predicting which word fits in a certain context. Now, the second stage, tuning it for a purpose, you do this with humans. So human, you pay a bunch of Indians sitting in a dark basement somewhere that interact with this agent for a given purpose. So chat. The GPT is the foundation that predicts. The chat part is what the Indians did for half a year for OpenAI. Just interacting with the GPT, with the foundation, until it produced something a chatbot would. So now you could ask it, okay, tell me what this sentence is in English. Gives you the sentence. Summarize it. Now put it in Dutch. When it does it wrong, it receives a bad. When it does it good, it receives good feedback. And this is the reinforcement learning bit. The agent learns in an environment composed of people giving their input. So this is called human-in-the-loop reinforcement learning. Usually in reinforcement learning, you have a defined reward function. If my goal is to put this salt here, in this corner.
The reward function is how close it is.
Yeah, exactly. Try to minimize the distance between the salt and this point. And eventually, after trial and error, I will get it here eventually. But for a chatbot, can you put in math,
no, you need
in computational language, what makes a good chatbot?
Yeah.
You need fucking humans to give their opinions.
Can you have a chatbot train another chatbot later?
That's what I'm trying to do now.
Nice.
Having chatbots training themselves. What's trying to say? Chatbot.
Chatbot training itself, but we're still at the point.
Humans.
Yeah, humans.
So this started human-in-the-loop reinforcement learning. Started with backflips, teaching a robotic body how to do backflips. Now, can you put this in math? Like you could give me just this distance minus this coordinate minus this coordinate, and try to minimize it to make it as small as possible.
Of course, because you can put all in math.
But can you put
no.
in human? Because we humans know what's a good backflip when we see it.
Exactly.
But we cannot define it.
Yeah, exactly.
Like what are the exact trajectories? Because you can make a backflip in different ways and with different velocities, and there's a huge variation of a backflip. But we still know a good backflip when we see it.
Yeah.
Now, how do we tackle such an optimization function that we're not quite sure what it is, but we know it when you see
humans.
it?
Yeah, I understand. I didn't.
You put a human in the loop. It gives correct, incorrect, good, bad, good, bad, good, bad, good, bad, good, bad. So you have a human teacher, let's say, and this works really good. Like for the backflip, you only need an hour of a human watching clips and saying good, bad, until the thing learns. Okay, a lot of computation on the part of the AI. But you don't need that much. Like it works pretty good and not that much human annotation.
Surprisingly fast.
Yeah. So that's what the Indians did. And that's how we can use a thing that can only predict what's the next sentence in a word, the next word in a sentence. We can use it as a chatbot. It's something for a particular purpose useful for humans.
I have an idea. You could use something like this with the good, bad. If you feed, for example, a lot of humans' health data and a lot of humans' interventions, and you look like, okay, this intervention, this outcome, this intervention, this outcome, this intervention, this outcome. And at some point, you specify the outcome and you let it give the people interventions. And then you say like, okay, it tells you, okay, you take this much creatine. Ah, shit, it doesn't work. Okay, you take this. And this way, it approximates the optimal function for the amount of creatine over time. But This would be really complicated.
Yeah, and you need to experiment with fucking humans.
Yeah, exactly.
Like, give them suboptimal creatinine.
Exactly. So
And we
this
don't
is-
need that.
But
We don't want that.
it's okay. Yeah, okay. Keep
Now,
going.
what we do with humans, so what they're trying to do now, what a lot of research with language models is now, is to shift it from fast thinking to slow thinking. Okay, right now, it's like you're riding, a language model is like riding a train, being on the train, and putting the rails as it moves.
Yeah.
Just riding at full speed and putting the things as it moves.
Yeah.
Now, what if we don't want speed?
We want accuracy.
We want depth.
We want to go into the right direction, not
Exactly.
like the one that just works
Exactly.
out. Like, yeah.
So we make it go deep. Tell it, okay, you have 2 hours to think about this and try different answers and go through different branches of arguments, thoughts, of assumptions, and only give me the most promising conclusions. Now, this is where a lot of research is done now,
So it's like talking to itself.
but I'm not sure about that. Like, this is what people are trying to do, but no one achieved yet. And they're trying to do it from 2 different ways. But one of the ways that I'm gonna do for one of my projects is grounding it. So not only having it look at documents when time is frozen. So at this point, it's frozen in time. It has knowledge about the world, that's for sure, because you can encode a huge amount of information about how stuff works in text. And people do it all the time.
You were talking about grounding.
Yeah.
Yeah, okay.
So at the moment it's frozen in time. It has no interaction with the environment. It only knows how the probability of stuff happening together.
And it was trained by humans. So
Now that's part of the grounding situation. But that still, it doesn't interact with an environment. It doesn't, when you ask it what happens if I hold my salt 1 centimeter from the table and then I let it go, it can tell you that it will hit the table. But it didn't learn it by doing it. It learned it by
approximately
reading
that
it.
this is the exactly.
And if you ask it, are you sure? Then it's probably gonna give you the opposite answer. It does this for a lot of things. Like the guy told us, I think you also were there in the boot camp.
Yeah.
Yeah. That's like, dude, when the Indians were giving feedback to ChatGPT, training ChatGPT with reinforcement learning. When they most often when they said, "Are you sure?" the answer was wrong, and the network learned that "Are you sure?" precedes the opposite of what I just said. So I'm gonna say the opposite.
So the most likely right answer if somebody is
Exactly.
Yeah, okay.
Exactly. So there is no deduction and induction
it's just
at the
most likely,
symbolic
yeah.
level.
there's like a mixture out of what is the most likely that it read and of what got the most reward on the
Let
training.
me take it back.
Yeah.
There may be some symbolic reasoning going on because people managed in large language models, in smaller ones, to track the circuits, the specific nodes, neurons, and that encode a certain concept. Like they managed to move in GPT-2's understanding the Eiffel Tower from Paris to Rome, just tweaking its parameters, figuring out where the Eiffel Tower is in the network's understanding of the world, and shifting it from Paris to Rome.
This is crazy.
This is insane. And this is exactly what I'm very interested in looking at. So, but it's still very much black box. You never know what it's gonna do or predict. So now what is lacking? The grounding. It doesn't learn what gravity is by playing like a baby, dropping shit off the table, by jumping, by walking, by interacting with the environment. Learns it from reading. Now you can make it to learn from interaction with the environment through some tricks that I'm gonna develop this semester. But that's still far from what we have now. Because we have to rip open neurons, just whole layers, like ripping out the olfactory neurons, receptors of a human, and plugging in new things that are gonna allow it to hear or see with the nose. So I'm gonna try to do that in the context of artificial neural networks, not biological ones. So that's one way to go at it, to ground it. Then you'll have, the guess is that it will take better actions since it learned it firsthand, direct experience, let's say, with interacting with the environment, than to reading about it. How on God's green earth are you gonna do that in the medical context? Because you can't give creatine to a million different people and see what happens. That's where another pipe dream comes in, which is making a system, an artificial system that can tell you that can come up with new laws of physics and communicate them to humans in an understandable language. It does not only have a bigger understanding of the world. There are classifiers right now since 2013, image classifiers that are better dog breed detectors than dog breed experts. So they have superhuman intelligence, but they cannot tell you why this dog is this specific breed as opposed to this dog. So they hold that understanding of physical laws, let's say, for themselves. There's nothing we can do, almost nothing, like very, very little that we can do
It's just an
to
incredibly,
get an explanation.
it's an
of why.
incredibly complex function that is like somehow really good at explaining which breed of dog it is, but we don't understand the function.
Yeah, exactly. So we don't understand the function, and it cannot, but we can distill it. Just like the pendulum. You swing the pendulum, you can put it in an equation. What are the dynamics of the pendulum gonna be given an initial position? How is the pendulum gonna stabilize or destabilize based on an intervention? We can do that. And we can do it with one line, with one equation that only takes in one variable, the pendulum's position.
Yeah.
Now you also need the derivative of that variable, the pendulum's velocity, but you can have one equation with one variable that tells you this. And humans came up with it. Now,
But
what they do right now, physicists, people that work with dynamical systems and AI, like the intersection between dynamical systems control theory.
so dynamical systems
artificial
is like a
intelligence.
super complicated formula.
So dynamical systems is a framework of studying things that change in the universe. Now it uses formulas to predict how things will evolve in time. And that's very much of interest to humans, because we want to know an airplane. Like that's what rockets use, planes use, trains use, electricity, phones, like everything runs in the framework of dynamical systems and control theory. Now what if we don't need humans to tell us what are the laws governing this thing? We can have an artificial machine giving us the formulas.
Giving us the laws
Yeah,
from watching it.
exactly.
Oh. So it gives us the... Oh, damn. So just from watching just from seeing who takes how much creatine and what the consequences are, it could give us the rules for how much creatine to take.
And what are the variables involved?
Yeah.
The variables involved in a successful creatine use, and
Like gender...
Just-
yeah.
just give you a whole array. Parameters, variables, constants,
Nice. That
and
tells
their
you...
interaction.
And it tell... Nice.
And then you can
Perfect.
plug in your case
Yeah.
of my weight, my
wrist-
lifestyle,
my wrist tolerance,
my money,
my money, yeah, exactly.
and then
My
you'll get the
gender,
answer
My holy shit, yeah.
of what's
So it would be a formula that we could understand as humans, or
At this point, no. Like at this point, the neural network still didn't come up to distilling it as good as humans. At least in toy cases like the pendulum. Because, dude, it's so cool. I want to show you the video. You have a neural network that's watching a pendulum move. Just a dude comes in with a hand, lifts the ball, drops it. And the neural network watches it thousands and thousands of times, like millions of times, watching a fucking pendulum swing back and forth until it learns to predict what the pendulum's position will be. It learns to predict it in time. Okay, we get the prediction covered. It's good. It does what a human does. Okay, we can look at the pendulum, look where it starts. At given time, you can say where it's gonna be kind. Now
not
it does
so
this.
complicated from a human standpoint. Yeah.
Now but it does it with millions of parameters, and humans do it with only one.
Lorraine.
No, the pendulum formula, because you only need the position of the pendulum. But you need to pull some tricks with the position, like multiply the position by some stuff, and you have some constants in there. But the point is, you only need one parameter. The rest are constants.
And
And the neural network has millions.
has like incredibly
So
complicated
it
long
gives you a
formula.
long sausage of an equation, but the human can give you
Yeah.
a one length thing, elegant, understandable, that gives you all the information you need. Now, people do this. And neural networks did for the pendulum to 2 or 3 variables. But still, it cannot say this is position. This is what this variable is. But it's been able to distill it, to distill the millions of parameters to 2 or 3. Now, if you tie that to a large language model capability and to a reinforcement learning framework of learning through the environment, through interaction with the environment, you can have an artificial baby that knows how human language works, knows the statistics of human language, how verbs come after nouns, and how adjectives work, and how human language roughly works. You have that understanding. So from the start, say something in our own language. What it produces, what it communicates, we can understand. It has a meaning for us.
Wait, which part is it?
The large language model. The language
Yeah,
model.
okay. So, okay.
So it learned the language statistics, knows our language, let's say,
By probability, by reading it.
by reading it.
Yeah.
It can produce codes that we understand as
Yeah.
humans, but they're not grounded. Those codes don't only refer to something experienced
Yeah.
from direct interaction with an environment. You get that through the reinforcement learning framework of letting that thing learn like a baby does. Having a system, no matter what that system is, let's say image segmentation, in which you feed it videos, and every time you see something that the segmentation algorithm was trained on, you can segment it, draw a boundary around it, and assign it a label, door. Know when it sees the environment. It also has a semantic property. The environment is not only raw stimulus of pixels and
It's also words.
waves, but it's also words, symbols.
So it can translate. Wait, stop. So we have a language understanding, probabilistic, and we have translating images to words.
Exactly. No, more like grounding symbols in environment. Because the environment is not words, the human environment in the world. The words are useful abstractions humans use. There's no word we can touch. There's no tree. There's only individual instances of trees that are all very unique. But you use these symbols. And these symbols are super fucking powerful. Brought us to the moon and back. So there's definitely power in understanding of the world, in using symbols. And there's definitely relevance for humans to understand the symbols used by these systems. You ground the symbol. Like your mother, when you're a baby and you run around and ask, what's this, what's this, what's this, what is this, what is this? And you point at everything that's around you, and you get the symbol back at you. Door, cat. You get a lot of input. Not only probabilities of watching everyone interact, and that's also super relevant in this circumstance. It would also work. Just having an AI observer that looks at everything, like a multimodal image, language, audio, physical observer that maps symbols, what it hears, what it sees, what it does. Now,
So this is how you could build an artificial human, maybe.
dude, yeah, exactly. Like, no one tried to. Humans take a lot of time to train. We're pretty useless up to 40. Like, you look at the baby, we put a lot of care in training a baby. And it's pretty useless for a very long period of time. Then you have a toddler, which is itself pretty frail and not that smart, although pretty cool to hang out with. You got a child and then a teenager, which is worse than a baby and a toddler combined. And we put a lot of care in humans and time. 18 years. Did anyone try to train one singular AI system for 18 years? Not to my
Ground
knowledge.
up, yes.
Although, dude, like at some points you got to pull the plug. We got hardware constraints, we got hardware improvements. You got to pull the plug on the training and take it from scratch because we can do it faster. But so this thing is guaranteed to converge the neural network in the limit. We don't have it in the limit. To converge to approximate the function, any function you give it. Okay, but there's multiple problems here because we want the general stuff. We want it to do multiple things. Even if you want a decision-making machine, it needs to understand physics for optimal decision. It needs to understand biology. It needs to understand math.
Okay.
It needs to understand
true.
human motivation. And the problem is task interference, or also called catastrophic forgetting, in which, okay, you learn to classify, you have the same network. It learns to classify numbers and draw numbers 1 to 10. Now, it does this perfectly, better than human. You flip those numbers around, just flip them 180 degrees. It learns to do that also. And you flip them back up, and it forgot everything. Worse than chance level. Now, if it cannot learn how to discriminate numbers if you flip them 180 degrees, on God's green earth, it's gonna remember how biology works, how humans work, how medicine works. Now, there are tricks, and I did this stuff from my thesis, meta-learning, they call it, and knowledge distillation, in which you have a bunch of agents, expert agents, biology, medicine, athletics, math. Then you have a student agent. And through some very smart algorithms, you learn to distill the knowledge in a pretty short amount of time from all of these agents into one. And the knowledge stays intact. If you go sequentially, you lose the knowledge. You go from math to biology, you lose all the math. You go from biology, physics, you lose all the biology and the math. And you only have physics. But if you do it all at the same time with knowledge distillation, then that's another way, powerful direction of going, of making a general knowledge system. But dude, like what I'm telling you right now, these are the directions. Large language model in which I'm going. Large language model because we care about understanding what the AI knows, especially when it knows better than us. Reinforcement learning, because we cannot afford to teach the thing by example, how the world works. The only way forward I see is to let it learn from scratch through interaction with its environment. And this thing, which at this point I think it's called neural differential equations and symbolic regression.
This is how you try to teach it like concepts, not only.
This is the learning the laws of physics and distilling them into as short of a formula as possible. But this doesn't even have a name at the moment. That's how new it is.
So my wish to build
So for your wish,
we need to build in a general one.
That's my guess.
Because
ChatGPT, there's a starting point.
Yeah.
It has a huge understanding of the world.
And if I feed ChatGPT my
complete.
obsidian and stuff, it can approximate maybe some good answers, but
it cannot point to things.
it can point to things, but it's more probabilistic than like.
Yeah, exactly.
It's no understanding behind
hard
it.
deduction
There's
like
no
humans
understanding behind it. Yes.
Or the reversal clause, like that thing pretty big in LLMs. Someone asked who is the mother of Tom Cruise, is the mother's name, and then asks who is the son of this woman, which is the mother of Tom Cruise, who is the son of this woman, who is the son of this name. The model says, I don't know. And this all in one conversation, just one text apart. So
okay, so it doesn't understand.
How do we hard code? But we don't have to hard code it. How do you do? That's the scientific school of thought I'm part of right now. They call it neuroconnectionism, in which we treat the project of AI kind of, as I understand, we treat the project of AI in the same way as we treat the project of understanding humans and the human mind. In terms of, okay, now why do we expect for this language model to know the reversal clause of if this person is the mother of this person, of person 2, then person 2 is the son of person 1. Now, where is that encoded in the human brain? Where is that? Because at the moment we cannot touch that. We cannot measure it. And we don't know the centers. Especially with higher level cognition, it's all spread around, all over the place. More of a circuit level. So if we understand how that is encoded in the human brain, we can replicate it in AIs. We can build certain architectures, use certain learning rules, put the system in certain environments in which it will learn the reversal clause. Now, what I'm telling you is get the decision-making system that can also that works better than ChatGPT.
Which one works better than?
To get a decision system that works better than ChatGPT, there's at least 3 directions I'm currently looking at to achieve that.
But it's probably not close. Unless...
Then you never know.
Okay, I think it's not close. Like, if
the
you
thing
try...
is, with AI, you never know where the next innovation hits from. Because on the one hand, you have
one line of code that changes.
Maybe it's one parameter, one hyperparameter that everyone uses 0.95. No one bothered to try 0.96. And that's all there is to achieving super fast. Because if we have super fast learning networks with capacity high enough, we can do whatever the fuck. Like I said, in the limit, a 3-layer neural network can approximate any possible function. And thus, if the world is a function, which is an assumption we're making here, thus it can solve any possible problem in the limit, under enough capacity of data.
And you have to give it infinite data.
Yeah.
And that's all.
That's also a big problem. But look, the humans don't have infinite data. Yeah. And we still do great things and advance our understanding of the universe and our control of the universe.
So wait, we have to find a way to make this thing understand concepts. Not like if we want to improve over ChatGPT, we have to find a way to train it not to only predict the next word, because of course I could train it on all the studies and stuff, and then it will kind of predict what the best dose of creatine is based on a lot of studies, but it will not really understand. If we really want to make it reason, we have to teach it reasoning somehow. We have to teach it
let it learn reasoning.
Or let it learn reasoning. And this teaching like a large language model reasoning is not really understanding reasoning at that point. It's just giving probable answers to reasoning.
No, but maybe
maybe
People,
humans
people,
do the
people
same.
talk
Yeah.
shit about GPT like, oh yeah, man, it's just statistics, probabilities is all it does. Well, what do humans do extra plus than probabilities and statistics? When you look under the hood, what do neurons do and neural circuits, if not firing of different probabilities with a certain variance and certain mean that shifts over time, given its exposure to different data? What do humans do extra than statistics? Now, to be fair, at the moment we can do a whole bunch more than ChatGPT. First of all, we can interact with the world directly. We can touch and feel and hit things in the environment. Second of all, we can do the reversal clause. We know whose mother is who and what that relation implies, and tackle it from all directions.
Okay, so maybe there is a way to train it to understand like those reversal clauses and stuff, or we just need to feed it more data, and at some point it will start to understand.
Like that's also the limit bit of, okay, just make it larger, give it more data. Because so far it seems that when we push the limits, when we go bigger and bigger and bigger, and more data, more training time, it works better.
Mm-hmm.
So eventually, if we're just doing it at scale, larger and larger, pretty much looks like it will converge to a human function.
And if you also so as an answer to the thing I want, it's nothing. It's probably like it's easier to try to build a general intelligence than, or it's not easier, but it's like it essentially makes a difference if you try to build a general intelligence or a reasoning system. Like there is no.
Well, it kind of does, in the sense of an embodied agent.
Okay.
Like I'm still undecided about if the system needs to have a body.
Maybe the embodied system. Maybe it helps. Maybe it helps.
Or it can only read 50 Wikipedia pages and come up with new physical laws.
Maybe the body makes it better. Like it's a possibility that the
Dude,
body.
like that's what I love AI. It's fucking alchemy. It's the closest thing we have to alchemy. Just we have lead. These imperfect neural networks are expensive, are discrete, are not continuous. The universe seems to be. We have the imperfect systems. The lead, which we have an abundance of. And we try to turn it into gold. The limit, the 3-layered neural network that's guaranteed to converge in the limit. And there's only 3 or 4 atoms away from lead to gold.
How? Yeah. Okay. But wait. One last time about. By the way, I'm gonna switch my studies to CSI. Okay. So to build.
Okay. Yeah. You don't wait. I'm gonna tell you about CSI. Yeah.
Yeah, we will talk about this as well. But if you want to build this understanding reasoning system, could we call
decision-making system?
Decision-making system, like based on information.
Better than ChatGPT.
Decision-making system that understands decision-making system, whatever understanding means. But there's no like nice way to like just build it. It's pretty much if you advance AI in general, it's like also advancing this. So it's not like this is like something separate. It's like.
And so that's also another discussion because some schools of AI are dead and buried right now. Expert systems are one of them. People strongly believe that you can hard code enough rules in a system about how the world works, about how to do reasoning, about what entails what,
like
about logical
math,
operations.
Yeah.
And it will eventually learn to take it all, man. Eventually learn to do anything. It will eventually be able to do anything. Now, that school of thought stopped being fruitful a long time ago and was an AI winter in the 90s, in which little to no funding went into AI except for the government of Canada, which still continued to pump some money into it, waging the battle, but then it turned pretty fruitful. Then deep learning came along, and the formulas were written in the 1970s and 90s. We now had the computers available and the data available to put those formulas to good use. Backpropagation, one of them. Backbone of the rebirth of AI in the 2010s. So you never know where the next thing comes from. It's Transformers also, 2019. People don't really give much of a fuck in terms of AGI when looking at Transformers. Okay, we have this system that can learn in a parallel manner. Good. We like parallelism. We have GPUs. They can do parallel computing. Good. Work in a parallel manner, and they can hold long-term dependencies, really long-term dependencies, unlike what they had so far, in which they had limited memory. The further you go in a document, the less you remember. So, okay, we got these, which are pretty convenient. And we prove that we can do translation better than everything else there is. All right, pretty cool. Now, it took 2 or 3 years until people figure out, okay, wait a minute, we can use this.
Well, that chatbot.
We can use this for a whole another type of stuff. And then they built GPT-1, then GPT-2, then Google came along to the party, and with BERT, and then Meta, with, I don't know what they have. So the point is, you never know where it's coming from.
Yeah.
Like even in Transformers, it took them 2 years
And suddenly,
until someone goes like, okay, let's do it at scale. Let's pump a bunch of data. Let's do it bigger. But it's not easy.
And it's always like the click. It's like, oh.
But
now-
it's not a click, dude.
Yeah.
Like it's alchemy. You just,
Yeah, but at some point somebody's like, this is I put this in, and now we're
Yeah,
closer.
yeah.
It's like suddenly it's like
but it's not always
Increase.
obvious.
increase.
Not always obvious. That's what I'm saying. Because the Transformer wasn't that much of a big deal initially. Like, okay, we can make translation better. All right, but AGI definitely wasn't on the table until they pumped millions and millions of dollars into training it.
Okay.
So
Wait,
my point is, you cannot just make general AI efforts. You have to choose
Okay.
sides
Yeah.
and make educated guesses. on the
I
direction.
agree, but I mean, like, if I want to advance to the how did we call it, decision-making system.
Yeah.
If I want to help build a decision-making system, it's just as good as helping advance AI in general. Or
It's definitely part of the AI journey.
it's like
It's definitely part of AI.
let's say the difference between I work specifically on trying to build this decision-making machine versus I work just on I try to find the best way to improve towards AGI. Just like those two opportunities, which would get the decision-making system faster. Or,
Man, dude, if I knew, I would have built AGI already.
okay. So just
Dude,
this,
go targeted, bro. Like, that's how I crystallize my thoughts.
but it's not.
If you're interested in the decision-making system,
And go.
don't fuck around with robotics.
Okay.
Go straight on symbolic reasoning, neural networks, symbolic regression, you wanted to know physics, go neural differential equations. You wanted to tell people new physics formulas, go symbolic regression. So we afford to have preferences in this battle. Now, there's also some AI in which you wouldn't be that interested in for this problem, which is more of the embodied kind of AI.
But maybe it's
dude, maybe you need the whole thing.
Yeah.
Maybe you need an artificial human to be able to have reasoning and to solve the reversal clause. You need the thing to have a body and interact with the environment.
But maybe not.
But maybe not. So definitely being targeted
It's better, yeah.
and focused and having your eyes on the prize. Now, okay, the field of AI is there's almost no AI, like no actual field. It's a whole bunch of other fields, of which we pick only what proved the most relevant for AI so far. So at one point, we didn't give a fuck about neural networks, about how humans learn, about the human brain in the journey of AI. We gave a fuck only about computation, transistors, rules, logic. But now,
there's no lot.
there's no beating around the bush. You need a neural network to do cutting edge stuff in AI. What was my point? Yeah, you can
go
niche.
specific.
Yeah,
Go specific.
But you need other fields.
But
grow AI.
Going specific means like but it's
Eyes on the prize. What do you want in the world?
But still, the likelihood of me needing like the whole shebang is pretty high.
What?
For
Like, dude. Okay, we can give you some stuff of what you just said.
Yeah.
But if you want everything, man, we're gonna solve a lot of other AI problems in the
meantime. Yeah. Bro.
Yeah, man, dude. So that's like the reinforcement learning bit came from psychology. That's from a developmental psychology idea.
Wait,
so it's definitely,
what was the reinforcement learning again? Just short.
The video, bro.
No, just say it a second.
This is reinforcement learning.
So at this point, Andrei showed me a video of 2 pigeons playing ping pong. They were trained by getting a reward every time when they managed to get the other pigeon to lose. And yeah, if you want, you can look at it. It's playing on the screen right now, but after we have no video again. Enjoy.
It's just how do you call it?
Wait.
Yeah,
when was
it's just reward and punishment.
Yeah.
There's a real
Yeah. So
If
just
a pigeon beats the other pigeon, it's,
just reward and like punishment and
letting the thing in the environment, giving it a reward.
like
function.
conditioning.
Exactly.
Yeah. This is the thing you can do with humans. You can also do it with.
But
Yeah.
man, how do you get where are the rewards in the human life? Like I'm now grinding my balls out in my master's program with no obvious reward. We go through life. There was a good quote in a paper. We go through life with little, almost none reward signal. We go through school, we go through high school, we go through university, we go through a job. Only to get to a job, we need 15 years of pushing, of investment, in things that are not obviously relevant for us.
We have like abstract.
So where's the reward signal? Because the pigeon, okay, that's right now.
Yeah.
You get the ball past the other pigeon, you eat. But what is our optimization function? We have no fucking clue. But maybe the neural differential equation and symbolic regression bit of a system looking at what humans do and then synthesizing it into a short, explainable, human understandable formula. Maybe that is gonna tell us what's the human reward function. There was a very cool paper that I found because of a thing you said about, man, maybe we don't need to split. Maybe we don't need to split the exploration versus exploitation. Maybe we can do both. So there's a paper that built...
Maybe exploration is the goal. This was my point.
That built curiosity in an AI system. And only through sheer curiosity, no reward, just information seeking, trying to maximize information content. That goes back to my idea on increasing the information in the universe. Just increasing the information content, an agent, and exposure to new information, novel information. Got it a third of the way of Mario, of Super Mario. So, and it also did stuff that it took regular agents on sheer reward and punishment way longer to solve. And this one only did things to see new things, to do new things.
So it was playing Mario Kart and it just went further because it wanted to explore the map.
Exactly.
Yeah.
Not because it wanted to win the game.
Just because it was nice, yeah.
And this is a different framework that's totally valid and proved very fruitful of curiosity-driven reinforcement learning. So what I'm saying is, dude, you don't need CSI necessarily. You can go all out psychology. Because the development so far, okay, there were a bunch of computer scientists.
Yeah.
Because these are the tools, the best tools we have right now to make intelligent machines. But the concept of reinforcement learning is incorporated from the field of psychology, and also the concept of curiosity, maybe, and a whole other concepts waiting there to be discovered and incorporated in AI.
This has been a Rational Optimization podcast. I hope you learned something. Guys, I made something cool. On my website, I made a list with my favorite episodes. So if you haven't listened to all the episodes that I already made and you want to know where to start, like there, I listed like in the rank of how much I like them, all the episodes, and I regularly, like whenever there are new episodes that I really like, I update the list. The link is in the description. Enjoy.